My talk today is called Linux the Story, from Torvalds through today. First of all, my lawyers tell me that I have to remind people that Linux is a trademark of Linus Torvalds in several countries around the world. We allow people to use the term Linux in their products if they wish. All that we ask is that they register it with us so that we can protect the Linux trademark. And of course, the use of it is free of charge. GNU is a trademark of the Free Software Foundation. They use it to protect the GNU tools. And Unix is a trademark of Xopen in several countries around the world. They use it as a standard to be able to say what is a Unix operating system and what is not. Who am I? I've been in computer science a long time, since 1969. I've been using Unix since 1980, and I've been using Linux since May of 1994 when I first met Linus Torvalds. I've had many different jobs in my life. I started off as a programmer, and then I became a systems administrator. I went to teach at a small university. I was a marketing manager for Digital Equipment Corporation, and I've been going around talking about free software and doing consulting since 1999. I've worked for some very small companies and some very large companies. I've also been both a customer and a vendor. And that means I have been somebody who's been waiting for a bug patch or for an enhancement to software. And I've been on the side of trying to provide that to customers who need it. So I understand both sides of the issue. We're going to go back in time to the period of 1943 to 1977, when computers were extremely expensive and physically extremely large, but logically extremely small and slow. The first computers, Mark I and Mark II, as an example, had a cycle time of 1/3 of 1 second, and you measured their memories in effect, words, not hundreds of words or thousands of words or millions or billions of words, but words. The computers of those days did not have operating systems. You only ran one program at a time. And therefore, like in this one, you had lights on the console so you could see what the programs were doing. And you had switches that you could flip to tell the program what to do at a particular time. Most of the application software was distributed in source code form. I remember one time having to pay 100,000 US for one copy of a compiler, and that particular compiler made the computer go perhaps 10% faster. Now, it seems like a lot of money these days to pay 100,000 US for a compiler. Now I'll remind you that $100,000 back then was a lot of money. But remember that the computers cost $2.5 million. And if it could make your computer go 10% faster, it was in effect saving $250,000. Or if you were trying to do real-time work, the fact the compiler was 10% faster meant that perhaps your real-time program would actually work instead of being too late in doing whatever it was trying to do. Shrink-wrap software did not exist. There were no computer stores. You couldn't go down to the computer store and buy your computer, because if you did, you would need an 18-wheel tractor-trailer truck to take it home, and 3-phase power to plug it in, and a 20-ton air conditioner to cool it. And there was no packages of software sitting on the shelf for you to take home either. So this is what it was when I started in computers. Now, a lot of people think that the computer companies, when they started to develop their operating systems, had some type of evil plot that they wanted to lock their customers into using their hardware. Trust me, I was working for those companies at that time. It never even occurred to us. What we were trying to do was trying to give people a chance to use the most efficient type of operating system. Because remember, these computers are extremely slow. And so we were tailoring the operating system to meet specific needs of customers. There was a computer one time called the PDP-11 computer made by Digital. It had 11 different operating systems on it. If we were trying to lock in customers, we could have locked them in with only one operating system. But we had one operating system that was good for batch, one operating system that was good for time sharing, one operating system that was good for educational, one operating system that was good for healthcare, and so forth. And then, of course, one of those operating systems was Unix. And we'll get to Unix in a moment. So we were trying to meet the customer's needs. We were not trying to lock them in to one set of interfaces. It's just that when you have a memory that's that small, you don't want to put a lot of functionality into each operating system for things that the customer may never use. Now, even back in those days, free software did exist. I was a student in 1969, and I joined an organization called DECUS, the Digital Equipment Corporation User Society. They were made up of people who were not professional programmers. In fact, as I was graduating from college, I had a professor tell me one time, "John, you'll never be able to earn a living writing programs." And I'm still trying to figure out if he was correct. These people were physicists, engineers, business people, doctors, chemists. Nobody had the title of professional programmer because they were just trying to do a job. And they wrote the software on these wonderful things we call computers. And then they said, what am I going to do with this? Am I going to try and sell it? Well, let me tell you that selling software is hard work. For those of you who are out there that it is your business to write and sell software, you know that. Because your customers expect you to maintain the software, document the software. They expect you to support the software, put in new features and update the software, advertise the software. And this was not the jobs of these people. As I said, they were physicists and chemists. They had real work they were trying to do. And so they contributed their software to DECUS. And DECUS would publish a huge library of this software that you could order the library for $15 printed on paper. And then you would go through and you would say, oh, I like that program. And for another $5, you could send away and get your paper tape delivered to you by mail. Now, paper tape held about 10 bytes per linear inch. And if your program was relatively small, you paid $5 for it. If it was larger, you paid $15 for it, because what you were paying for was the tape and the time it took to duplicate the tape onto the media and to mail it to you. And you would get it, and it would be wonderful. And then you say, well, what am I going to do with it? Well, obviously I'm going to use it. But see, I was a college student, and $5 back in those days was still a lot of money, because $5 would buy you 10 pitchers of beer. And so as a college student, I had a choice, a text editor or 10 pitchers of beer. And I think you can see what direction I went, you know. But this was free software. And what I could do is I could go to the school store, I could get some paper tape, and I could put it, let me see if my laser beam works. Oh, I don't know if it has a laser beam. I could get paper tape, and I could put it on my ASR 33 teletype, which is that machine in the lower left-hand corner, and I could duplicate the tape, and I could sell it for $1 a copy. And so after I sold 10 copies, I not only had back all the money I'd paid for the text editor, I had all the money I'd paid for the new paper tape, But if I sold another 5 copies, I also had 10 pitchers of beer. And that, of course, was very important to me. And the customers that gave away this software, why did they give it away? They said, well, I needed the software for my own purposes anyway, so why not give it away? Why not help somebody else? And maybe I will go to a DECUS conference and I will meet this person, and they will say, hey, you did a great job, let me buy you a beer, or let me buy you dinner, or let me give you a job. And all of these are the same reasons why people write free software today. So the library kept building and distributing this software. Now, in 1969, several things happened. As I said, I was a college student. And in 1969, an operating system was developed by AT&T in New Jersey called Unix. And at first, there were only a few people working on it, a person by the name of Ken Thompson and Dennis Ritchie. But it started to become more and more and more popular. The first computer they put it on was a PDP-7, but that rapidly ran out of space, and they moved it to a PDP-11. And they kept moving it to different computers. And they said, well, as we move to different computers, we have to make the operating system more portable, easier to move. As the computers are becoming faster and faster, there was now this trade-off that was happening of saying we can give up a little bit of the efficiency for the portability of the operating system. The memories are becoming larger. Therefore, we can give up a little bit of that efficiency for having more information in the system to make people's lives easier. And so the trade-off in cost and speed was acceptable for this operating system called Unix. And they decided to make it very portable across different hardware architectures because they realized that the trade-off in efficiency of time it takes for humans to make their programs different, to fit different architectures, was traded off for the machine's efficiency. And they started to develop software interfaces in Unix, which we enjoy today in Linux. One more item that happened in 1969, little recognized except for 2 people in Helsinki, Finland, was a person named Linus Torvalds was born. And we'll see more about him later. Unix started to spread through various universities, Columbia, University of California, Berkeley, Carnegie Mellon, Germany's universities like the University of Cambridge in England, universities in Germany. But Unix was not free. A lot of people think that Unix was free, but it was not. Unix was owned by AT&T, and they had copyrights on it. And they charged universities about $350 US to have a campus-wide license for Unix. But that was if you were a research university, like Columbia or Berkeley. If you were a small university like mine, the charge was $160,000 US per CPU. If you had 2 CPUs, it was $320,000. 3 CPUs was $480,000. You can see that the telephone company was not into volume discounts. And of course, I couldn't afford this. So my students could not see the source code for Unix. Even the BSD code that came from the University of California, Berkeley, was under the same source code license. And because of this, Unix systems started to fragment. There was an organization called Unix that everybody who belonged had source code licenses for Unix. And we were used to exchanging the source code back and forth that people were working on. But one day, a person from a company called Sun Microsystems showed up. And they talked about the things they were doing with Unix. And we said, hey, that's great. Let's share the source code. Let's try and use this to make it better. And they said, I'm sorry. Our company is closed source, binary, and we can't exchange it with you. And everybody started to boo, hiss. But over the years, the booing and the hissing became less and less because it became more and more normal that companies were only distributing binary licenses of Unix. At the same time, in the period of 1977 to 1983, microcomputers started to appear. Computers like the Apple II and the IBM PC. Operating systems like CP/M have been around. And so people were more and more used to having binary-only copies of software. Computer stores started to appear, and people would see boxes of software on a shelf. And so a lot of the people from that period, or started using computers after that period, became used to buying binary-only software and didn't realize what you could do if you had the source code. And the economies of scale made this happen. Companies started up, like a company down the street from me, that had 100 engineers, and they had 1,000 customers, and I was one of them. And one day I found a bug in their software, and I called them up, and I got the president of the company on the telephone. And I said, I found a problem with your software. He goes, yes, I know. I know what the problem is because I wrote a lot of that software, and I can fix it today. And if we fix it today, we can test it this afternoon. Oh, that's good. And he could say that because he was the head of quality assurance. He said, if we test it, we can have it out to you this evening. Oh, that's great. He could say that because he was the head of the shipping department. And sure enough, the next day I got 2 8-inch floppy disks in the mail, and the software was fixed. Now, if each one of their customers had found 2 problems or asked for 2 enhancements to the software, that's 2,000 reports coming back to the 100 engineers, or about 20 problem reports per year. That's an acceptable number. But let's take a look at what happens today. Their company has grown. They have 150 engineers. Their software no longer costs $1,000 a copy. It only costs $29.95. But they have 4.5 million customers. And today, when you call up the company, you no longer get the president on the telephone, nor do you get the chief programmer, nor do you get the head of quality control, nor do you even get a shipping clerk. What you get is a voice that says, please press button number 1 for sales, button number 2 for support. You press button number 2, boop, and then you get music, music. And then after about 20 minutes, you get disconnected. That is what we have come down to, folks. And the fact is that you can no longer get the bug fix that you need or the enhancement that you want, because it's not that the companies don't want to give you good service, it's because they can't give you good service. Now, there was one person in 1984 who disagreed with all of this, and his name was Richard Stallman. He was a student at MIT, and he said, I don't like having binary-only software. I want to have the source code. And he formed a project called GNU, which started to write pieces of the Unix system from scratch with source code. And during the 1980s and 1990s, this body of code kept getting larger and larger. And he was smart in the fact he wrote the code that would run well on a variety of different operating systems. Emacs runs across more operating systems than any other piece of code. The GNU compiler suite goes across more architectures and operating systems than any other compiler. He did that because if he had started with writing a kernel back in 1984, the kernel would be uninteresting today. So he wrote the pieces of code that people wanted to use. Also, it was joined by other pieces of code like sendmail and bind, which are also open source pieces of code and handle more email and run the internet like we enjoy today. At the same time, the University of California, Berkeley freed up their code from having to have an AT&T license, and out of that we got NetBSD, FreeBSD, and OpenBSD. But in 1991, almost all of the code necessary for an operating system existed, except a really good kernel that was completely open. And this is where Linus Torvalds, who is now a student at the University of Helsinki, decided that he was going to write a kernel just for fun. It wasn't going to be a big, impressive project. It was just going to be something that he wanted to do because he thought writing kernels was fun. And by 1994, version 1.0 of the kernel had come out. He, of course, was joined by thousands of other people in doing this. And by 1994, the Linux kernel had come out and distributions were beginning to appear. Distributions like Soft Landing Systems, Yggdrasil, Ameritech, Slackware, and then others followed. In September of 1998, the Linux systems have become used by so many people that database companies like Oracle and Ingress and Sybase decided to port their commercial databases to Linux. In October of 1998, companies like IBM started to support Linux systems. Red Hat was showing support. In October 2000, the dot-coms failed, but at the same time, embedded system companies started using Linux to create their embedded systems. And by the year 2001, Linux was the most used embedded operating system for new products. The Linux kernel was used as the basis of Android, Firefox OS, and a variety of other systems that are coming out. In winter of 2003, Red Hat software became profitable and has been profitable every year since. So for the people to say, I can't make money with free software, there's lots of examples of where you can make money. It's just you're not selling the software itself, you're selling a service that's based around it. When we say free software, what are we really talking about? Yes, in a lot of cases, the software is free of cost. But in reality, there is no such thing as truly free of cost. Even a mother's love has a cost.
If you love me, you'll take out the garbage. If you love me, you'll feed the dog.
But it is close enough to being free that interesting business models can happen. What we're really talking about, however, is the freedom that you have to change the software to meet your needs. And the freedom because the person who actually owns the software is you. You know, when I first got involved with Linux, there was a huge effort here in Germany to support free and open source software. In fact, Germany has been one of the countries that has led the issue. KDE was started here, Qt was started here, a lot of things were started here in Germany. And so, naturally, Germans believed that Linux, in a way, belonged to them. But when I went to Moscow in 1996, there was a large Linux community there too, and the Russians believed that Linux belonged to them. I went to China in 1998, and I went into a government office, and there was Red Flag Linux being sold in the post office, and red flag Linux looked remarkably like red hat Linux. But it was legal, and the Chinese were selling it. The Turkish people also believed that Linux in a way belonged to them. And when you go to France, well, the French believe that everything belongs to them, but that's a different story. But Linux belongs to everybody, because everybody, even if you don't contribute to it, owns the operating system. I talk to government about free software, and I say to them, would you trust your weapons, your tanks, your planes, your ships to a company that will not show you the source code for the bits that are going into your systems? Now, I live in a strange country. I live in the United States, and we don't think anything about putting Microsoft software into our tanks and our planes because Bill Gates is a loyal U.S. citizen. But if you talk to the people in Iran about their centrifuges, they might have a different story now. And what you have to think about is your own country and what happens for your own security. You should be looking at the source code for your compilers and for your operating systems to make sure it doesn't have Trojan horses in it. How long should your email system last? You know, when we had paper, we still have the letters of George Washington and the letters of Napoleon that were written that we can look at them. But how long should you be able to read your Constitution? Until the next generation of Open Office XML? Or what would happen if the Constitution of Germany or if the EU had been written using WordStar? Remember WordStar? We can't read WordStar anymore. These are things you need to think about. And it's not just about disruptions like wars. You know, companies go bankrupt. There was a company called Nortel in Canada, second largest telecommunications company in the face of the planet, went bankrupt in a matter of months, and their equipment is no longer supported. Or the fact that companies simply drop support. They can't afford to support multiple editions of their operating system over time. I've been told that on April the 8th of 2014, the support will be dropped for XP again. You need to be able to plan, and free and open source allows that decision to be done by you and not by some company. A lot of times today, I go to a university and they say, we teach closed source products because that's what our students are going to be seeing when they leave the university. And I say, okay, the duty of a university is not to train employees. The duty of a university is to teach people how to think. The duty of a university is to create the leaders of tomorrow. And when you're doing that, you have to be able to make people sift through data, find what is the truth, and then throw away the rest. And this is what you're trained for in your undergraduate degree. If you're training people by teaching them how to use a product, then when Microsoft goes from XP to Windows 7, you should take back their diploma. But if you're teaching them how to use an operating system, then their education will last for many, many more years. So what you should be teaching people is how to use an Office product to extend your business, not how to use Microsoft Office. You should be teaching them how an operating system works and what are the things to look for, not any specific operating system. Software Libre is perfect for this, because if you wanted to teach people about operating systems, you can show them Mach, which is a microkernel, the Linux kernel, which is monolithic, the BSD kernel, a lot of different kernels to show people not only what the software does, but how it does it. And people say to me, well, you talked about government and education, what about business? And my answer back is that government and education are businesses. And that is, when I talk to 4,000 business people in a room, I ask them 4 simple questions, and I will do it here. How many of you have ever had a problem with closed source, binary only software? How many of you have ever taken the time to write a well-worded description of that problem and give it to the company who made the software? Of the people that did that, how many of you have ever gotten back from that company a fix or a well-worded workaround for that problem? That was pretty good, actually, because normally when I ask that question, everybody in the room raises their hand on the first one. 3/4 of the people have their hand raised for the second, and then only 3 people have their hand raised for the third. And I say, Mr. Gates, you don't count. This is a very poor description of what we expect out of software companies. However, it is very true of today. I'll ask the business people one more time, and I'll ask you, how many times have you actually changed your business to make the to fit it the way the software worked? In other words, the software didn't allow you to do exactly what you wanted to, so you changed your business to make it work. This costs you time and money. And it would be much easier to hire somebody, in most cases, to change the software to fit the way your business worked if you could. But you can't, because somebody else owns that software, not you. This is why every once in a while you see a report that comes out from a large company in Redmond, Washington, which talks about total cost of ownership. And what they're talking about is the cost of buying the licenses, the cost of support over typically a 5-year period of time. In 2 years ago, they generated another report which said that the total cost of ownership of open source was now equal to the cost of proprietary software. And that included the fact you didn't have to buy the original software license. What they were missing was the fact that you can change the software to meet your needs, the open source software. And that gave you a greater value of the software. Total cost of ownership is not important after you buy the software. If you can afford to buy the solution, that's the most important thing. But after that, you should be looking at return on investment, not cost of ownership. Today, there's approximately 500 million desktop computers in the world which are general purpose. About 450 million of those are Microsoft, and 40 million of those are Linux-based, and 10 million is everything else, including Apple. But the question is, what is the future of the desktop computer? A lot of people say it's going to be mobile phones, and that's what people are going to be using. But the point is that out of those 5 billion people, they haven't selected their operating system yet. They're not tied to Microsoft. They're not tied to any particular operating system. And they're going to use the one that is the cheapest and most flexible for them. So here are some examples of people who have switched over to Linux. And Germany has switched its parliament to using Linux servers and a lot of their desktops to using Linux. Thailand sold over 1 million low-cost computers to people who needed systems and needed free software. China has made Linux their operating system of choice. They've decided that they're not going to have the Business Software Alliance come after them for software piracy. And they're getting about $700 US worth of functionality for a $70 USD charge. And in Brazil, which I call the shining star of free software, they've managed to blend together government, industry, and the community to solve problems that the government has. And so here are a variety of different projects from the early days of Linux that are still going, and each one of them was hugely successful because they could change the software that was given to them and make it do what they needed to. And with that, I'll open it up for questions. Thank you very much for coming.
Many thanks, vielen Dank. Wenn jemand eine Frage hat, dann bitte melden. Ich käme mit dem Mikrofon vorbei und dann wäre es auch auf der Aufzeichnung. Any questions? Don't hesitate to ask questions.
While they're thinking, I'll also point out that over there I have a Raspberry Pi computer running XBMC as a media center. The Raspberry Pi, if you're not familiar with it, is a $35 computer system. And I have it set up so that it's basically attached to the back of the monitor along with the storage, but you could also store your media and your movies and your music over the net in the cloud storage. So come on over, take a look at that.